How's it going? Can everyone hear me? Hello, hello? Can everyone hear me? I can hear myself, so I'm gonna call that good. How is everybody doing? We can make our announcement so we officially go live. We are live on Twitch right now. Compiler. Can I do like squared? Is there superscript? Is that a thing? I don't know in Discord if that's a thing. Compiler. No, I'll just say compiler part 21. I'm not creative enough to know what I'm gonna do today. Looks good to me. Hey, Eternal Wild Fox says hello. Grammar 2 Parser Boy says first. Almost, Grammar, almost. You were nearly there. It's so good to see you. Thank you for tuning in, Eternal. Thank you for tuning in, Grammar. I really appreciate it. As usual, that notification reminds me that my phone is not on silent, so I will fix that. If you have not checked out the YouTube, we are now at 250 subscribers. It's incredible. I would have never imagined that this would have happened. So, yeah, that's amazing. We have 250 subscribers on YouTube. Would not have pictured that at all. The 6-hour videos on pointers, I would not picture to do well, but those are the ones that do well. So, here we are. But yeah, I'd just like to thank everybody on the YouTube and the Twitch. We actually had 5 follows on Twitch just overnight when I wasn't live. So Daniel B, Sir Aid, Nakadori, Snarlferb, and Reserved Keyword, thank you for the follow. Shouts outs to yous. Eternal, how's it going on your bytecode interpreter? That's what you're working on, right? Let's see, full compiler. Let's just go source main. Grammar says, I really like my units feature of backling. This makes backling kind of unique. It makes it very unique. I've never seen that before, but it's very cool. So if you don't know what we're talking about, because this is kind of context from the Discord, in Discord discourse that we've been having, basically, most languages, also I gotta load unmode. I gotta add this like as an auto load. Load file. Unmode. Perfect. Most languages, Grammar says F# has this feature. I don't think most people know F# is a language, so I think you win there. I think if you say F#, they'll be like, is that a note in music? Most people won't know. Eternal Wildfox says, thinking and building how to build a class which can keep bytecode into memory. Nice, like a serializer. Adderson28 says, hello Lens, hello everyone, how are you doing? Hello Adderson, I'm doing okay, I just woke up. How are you doing? I hope you're doing well, Adderson. Thank you for tuning in. We were just discussing Grammar 2 Parser Boy has a very unique feature in his language, backlang, where you can assign a unit to a type. So basically, for example, an integer, you could make it an integer of meters. So this, like you can do in math, like meters don't match up with feet, right? So even though they're both integers, they may have different units. So by assigning a unit to a type, you can actually like type check that the unit makes sense. And you can also do unit conversions, where like if you had C, which was an integer of feet, then you could equal like B times 3. But this would be meters converted into feet and stuff like that, which would be around 3, right? Because it's an integer. And you could also type check that only valid conversions happen, and if you assign to an integer that's not meters, you could have all sorts of semantics, but it's very cool and allows, I think, much more clear programs to happen, because sometimes you have an integer that is that means something very specific. And I think in game development that would be very sweet if you could have like the units match up with the game engine units, because then you could just write, oh, this is 3 meters, and it would work. It's pretty cool. But yeah, that's a very cool idea. I like that a lot. Grammar to Parser Boy, I really like it as well. It's so cool. So Eternal Wild Fox says he's working on building a serializer of bytecode into memory. That's awesome. That's gonna be that's gonna be rough, I think. It might not be too bad though. It could just be like a, because in, I don't know how it works in C sharp, but in C you can just serialize any structure. That's what they're for, pretty much. That's what even like fwrite is made to do. It's made to write structures to a file in a row. Grammar to Parser Boy says, and you can simply define a custom unit with unit feet. Nice. So you could do like, is it scoped or is it only allowed on global? I assume it's only allowed in the global scope. Eternal Wild Fox says, not going to write to a file though. I see, so you're just trying to figure out how to represent the bytecode in memory within a structure. I get you now, Eternal. Eternal says, it is not a compiler. That doesn't mean you can't save files for later, right? Just do a little caching. So you could say like unit feet, and that would create a new unit of feet. Could you then do your own unit conversions? Could you do like unit yard, right? We have yards in America, which is 3 feet exactly, 36 inches. So could you do like equals feet times 36 or something? Like, is that a thing yet? Or can you do like unit conversion? I don't know. I'm just picturing like all the semantics that are possible with this new idea. I've never heard of it. It's in scope. That's really cool. In C sharp, you can serialize, deserialize structures as well if no member is a heap object. Well, that makes sense, because then you'd save the pointer. That makes a lot of sense. Grammar 2 Parser Boy says, not now, but it's planned. That's very cool. You are a genius, Grammar 2 Parser Boy. I think that's very cool in your language. Like, the idea of your own units that are on top of types. It's like an abstract layer further than types. It's really cool. Okay. Okie dokie, okie dokie. What are we gonna do today? I think we're gonna go through and try and do, like, just fix where we're being dumb. And also lambdas are not being handled correctly at all. And also if isn't being handled correctly at all. If we look at the to-do, pretty sure that's talked about right here. Yeah. It is, if, should have put that in something. If is parsed basically, but context is still not handled. Shouldn't be too hard. What an... I hate past me. Past me? Okay, if anybody can find or remember when I said this or wrote this, we should go back and shame him, because past me should not have wrote this. Now it's going to be incredibly difficult just because the universe wants to spite me. Okay, so work on parsing in Cogen of if conditional statements. Let's do that. So parsing of an if conditional. We have a stack operator, right? In our stack operators, we have stack operators. One of them is if cond, which is if conditional. There's no reason this has to be short, by the way. We don't really write this out all the time. We can just say if condition. I think that's the literally only 2 places. Yeah. That's better. So we have if condition as a stack operator. So this will be entered. Ooh. This will happen when we find an if keyword. We will create an if conditional node in our working result. And then we will create a conditional expression, which is a child of this if conditional node. And then we will set our working result to conditional expression or condition expression, which means that the next thing we will parse into upon continuing will write into working result, if that makes sense. So then we will basically just say that working result, yeah, basically just parse into working result. So this will parse the next expression, go back to the top and do more things, but this time into the if condition, and we set a stack operator to handle this next expression after it's been parsed, if that makes sense. So we create a new stack, parsing stack, set the operator, and set the result to the working result, just because that's what working result is at the time. And the if condition writes into the if conditional right here. No, into the condition expression, and that's working result. We could also write condition expression and be a little more clear here. I think that's better. And then this continuation, we can put this down here with continue. That makes more sense to me. LanderXT says do more things. How descriptive. Well, it does literally everything else. I can't say, like, I could say it parses an integer, or it parses an at, or it parses an and, or it parses a lambda, or it parses a... I can't go through the whole list. LanderXT, oh, it's great to see you. It's great to have you in here. Eternal Wild Fox was actually the first one in here today, Landar. But you are here today, so I appreciate it just as much. It's just the universe is backwards today. Schedules have changed for the weekend. I guess it's weekend for me. Alrighty. So we have if that creates an if condition. We will parse into the condition expression, and then we'll continue. So we'll parse in either an integer or some crazy expression into the condition expression, right? Could be a function call, could be a lambda that's then called, ideally. That should work eventually. LanderXT says, I saw your stream notification on my phone while I was doing this thing called going outside. Whack. You've been outside? Wow. Imagine going outside in 2022. I'm just messing with you, Lander. That's really awesome. I was outside this morning as well. Oh, so good. Imagine writing a compiler in 2022. Oh. Okay, so we create an if condition. We parse into that. Then we go back up to our operator and we'll say, okay, so now working result should point to the thing that we have parsed, right? The condition. So we want to then, after the condition has been parsed, expect that next up we get an if body. That makes sense because we don't have semicolons or anything, so if there was an if with no body, it would make things very confusing. Okay, so we expect open brace. If we find it, if we don't find it, what do we do? We say if expression requires a then body. This doesn't really say what to do. We should say expected open brace after if condition. Yeah. If expression requires a then body. I think that's fine. That's not too crazy. We'll go with that. Unless it is crazy, then chat, you gotta let me know. You gotta let me know when I go crazy. Okay, so for an if condition, we must have, or at least we expect, an opening for the body. We then create a new node for the body and set our stack result next child. So this is the if condition, if you remember. We set that before, the conditional expression. I say conditional too much, it's condition expression. So then we set the next child of that because it's the child of the if node itself, right? So we set next child, which sets the next child of the if node, not the if condition, but the if node itself, to the body. And then we create the first expression, make that a child of the body, and I assume we parse into that. Look at us. And yes, we return a status of stack handled parse, which means parse into the working result it has been updated, which it has. Alrighty. We also update the stack operator to a new symbol, which is the if-then body. So the if-then body, right, because then we need the stack. Each time we parse an expression inside the body, we need it to increment our working result to the next expression in the body. So then we need a stack operator for that, which we have, if-then body. We set the stack body to if-then body. I honestly don't know if this is needed. To do. Is this needed? I don't know if we ever use stack body anywhere, but we may. And then we have stack result, which is our first expression of our if-then statement, of our if-then body. Yeah. So we create like a little framework and then parse into the first expression. So then in if-then body, we have parsed another expression. Maybe it's an integer or a function call or anything, a dereferenced variable reassignment. Who knows? In any case, we've parsed something else and we end up back in the stack operator because we didn't get rid of our if stack, so we still handle it. And we expect a closing brace, so we're trying to find the end of the body, which we also do. We allow empty bodies up here. I didn't talk about, but that is a thing. We have a little shortcut. But anyway, we parse something, then we check for the end of the body. And if we don't find the end of the body, we jump here. And we end up creating a new node for the next expression in the body. And then we just update our stack result next child, and then set our stack result to that next child. So this is kind of taking a linked list and updating our pointer. So we have a stack result, we set the next child. So we kind of have result next child. And then we update it so that we just have result, which is updated to next child. So I guess you could kind of write it like that. And then basically we just update next expression right into that, parse into that, because we didn't find a closing of the if body, it continues. When we finally find the end of the if-then body, then we look ahead for an else. This is not a to-do anymore. We look ahead for an else. And what do we do? What do we do? So if done or found. I don't know if I like that done. You know? Because if done means that they're like end a file. There's nothing more to lex. So this would mean that we accept things like if you did if, for example, like number, then you could do like that because it's at the end of a file. But I think that is horrible, right? I don't think that's the way to do things. So we need to ensure and say, if not done, or if done, yeah, so if done, we're gonna prep an error in our error. That is an error of syntax that says end lexer completed. I'm just gonna say end of file. End of file reached before end of if-then body. Sure. Sure. I am, okay, so that's better. I don't know why I wrote if done or found. So now if we lex and look for this and we're done, like, oh, that's not okay. We can't be done lexing. we need something here. It's either this, right? it's either another expression in the if-then body, or it's a closing. It can't be anything else. If there's nothing there, then that means we have an open body. I didn't set up any build commands, so let's do that now. We're going to build our debug build tree. We're going to run the executable it generates in verbose mode and point it to point, which is our little test file. Oh, then we have to run it from the proper place. Ooh, did I? Hey, look. End of file reached before end of if-then body. It worked, chat. Eat the worked. So now we have this, and it should be fine. Malformed or misshapen parsing context encountered during type checking. Exited with code 5. Yeah, it's going well. It's going well. So that works. Is it still just this? That's the malformed or misshapen. But this causes an exit with code 5. Oh, because we don't have A. That's why. We're causing the whole thing with contexts to happen. Still code 5. Yeah, so we have problem with if contexts, which we'll notice we haven't talked about at all, which is the issue. LanderXT says, how the Great Fire of London created insurance. What? Grammar to Parser Boy says, how would you check if a certain type can be implicit casted to another type? I don't want to do a massive if statement or massive switch block. Any ideas? Yes. Grammar. I don't know what they have in C#, but in C, that is suspiciously sounds like a hash map to me, right? So hash the type that is being cast, value, so this is like the key, right? But value or key is going to be a linked list or something, right? Linked list or some container structure to contain implicit cast, valid implicit casts, right? Does that look too insane? Maybe I don't understand your problem, but this was immediately what came out to me. Like, make a hash map where the type you're trying to cast is bound to a list. So casted type is bound to like a list of other types. So it'd be like integer, right? Stuff like this. Integer 32, integer 16, right? If you wanted to do stuff like that. So this might be like an integer, right? And it could be your casted type bound. It might be like an integer 8, right? Grammar to Parser Boy says, yeah. Awesome, hopefully that helps. Because you could just bind your casted type to a simple data structure that you can search through, some container. A vector maybe even, if you want to iterate fast. But yeah, something like that. Then you could just store a list of something like that, and if you find your casted type and the type you're trying to cast it to, then you're just comparing types as you go in this linked list. And I think that would minimize actual like time it takes. Like it wouldn't be expensive computationally. LanderXT says, after the fire, much of London needed to be rebuilt. King Charles II declared there would be collections at churches across the country, blah, blah, blah. I'm not saying blah, blah, blah. He wrote 3 paragraphs. I'm not reading it all. Basically, they didn't raise enough money. But the giant fire meant that people were like, oh, maybe we need to worry about fire and pay money to people who have their houses burned down. So they created insurance. Crazy. And London was first called Londinium. That's hilarious. Was it really Grammar to Parser Boy? That's crazy. So Lander went off on the London fire. He's in history class right now. Grammar also knows about this, apparently. I'm American, so they didn't teach me shit about history. I went to a public school as well, so that didn't help. What do we got? What do we got? So in the if-then body, when we're parsing the body of an if, is it not true that Lander XT says, I'm British, so that probably helps my cause. That would definitely help your cause. I understand now. I didn't know if I was being memed or if I was being knowledged. You know what I mean? I had to figure out. I'm a boomer in zoomer territory, you know what I mean? I may have copied that from the first Google result, at least partially. I would hope so. I would hope. I thought it was just like the Wikipedia article. Grammar says a friend will move to London, and I might move to London in future too. That's crazy. Londinium. The destination of the people, apparently. So should we warn about an empty if body? We probably should, but we have no way to have warnings, and that's going to be a whole thing, so we're going to have to pass around a warning stack or something. So that's going to be a thing. Yeah. Or we could just emit them, like print them out as we go. I don't know. So when we enter an if-then body, you see this to-do is already kind of putting us on the right course. Should new parsing context be created for scope of if body? Yes. Because I don't think an if body should be like embedded in its parent scope like it currently is. So to highlight this, maybe we can do like a this file is so old, we can't use this. We're going to do conditional 2, because I am uncreative. And conditional 2. Hey, look, it works. Program, none. Easy. Easy. LandoXD says Londoninium, Londiniensium, Londinio, Londiniensi were all apparently used. What? So either everyone can't spell, or they never decided the name, or both. That's incredible. Londoninium is really funny. Londoninium. Should new parsing context be created for scope of if body? So the current issue is if we say like if1, right? And then say some number is an integer equal to 69. I'm pretty sure this is valid, which is kind of scary. We still get exited with code 5, so we have some issue. Is it with ifs? We have an unknown symbol. We have a non-unknown symbol, so this works. But putting it here, we exit with code 5. So we definitely have some issue with ifs. What do you think it is, folks? What do you think it is? So we parse into the working result, and the working result is our condition expression, which is a child of our if conditional node, which is just our working result. Right. All right, all right. One final London naming fact. All right. The Lundy part of Londinium is a simplification of Lindane, which means pool of the Thames in Welsh. That is amazing. There's some history there. in America, we have very stupid names for things, and there's really not a reason historically like that cool. It's not like, oh yeah, it's named after the river that goes through it. It's like, yeah, it's this is called Paris, Tennessee, and this is what should we name this one? Seattle, based on the people that were there before us. It's really funny. It's like we not so great on the naming of things over here. It's like, just make it up. But we've only been here 200 years, so it's always fun to go to other places and you like see the history that some places have. Like people have been here for a long time, and these people have been here for a long time. It's cool. It's like everything is so integrated and feels so natural. Then you come to America and it's like desert full of people. Wonderful. Okay, so I think America is just all the people that were kicked out of everywhere else. If I have to guess. Grammar 2 Parser Boy says, in my town we have names for streets like Beautiful? I think you mean Beautiful Way, or Main Way, Lamau. We definitely have a main road in every city or town. There's like Main Street or Main Road, or there's a main in every town, pretty guaranteed. Usually there's multiple. So why is this if conditional causing us so many issues? We basically add a child to our working result, which is a newly allocated node. We try and do some things with that node. We parse into it, right? So in this example, we parse an integer. It's pretty easy. So we parse this integer, which skips us to here. We look for a binary infix operator, which we definitely do not find. And then we go, okay, if not stack, break, but we created a stack, so we handle the stack operator. And the stack would have been the if conditional, which means that we expect this, which I assume we're doing. Let's just say, do our little fun tests. Yep, so we're here. We're getting to here and we're expecting an open body. There's no closed body, or at least I would hope. Exited with code 5. Okay, so there's no empty body. We're not screwing up the lexing or anything. So then we update the stack operator to a new symbol, which is if then body. We set the body to if then body, and we set the result to if then first expression. We set the working result to if then first expression, the status to stack handled parse, and return OK. Which means that down when we handle the stack operator, we're gonna break out of the while, because we're gonna handle the stack operator. We'll handle the error if there is one, but then we'll say status equals check. It's not, it's parse. So then we will get down to parse and we will continue. In which case we'll be back at the top, parsing into the if body, which you would think just parses a variable reassignment or a variable declaration with initialization, excuse me. This is what you'd think. So if we remove the initialization, that doesn't work. So it's not that. Is it just, let's see, can we do a reassignment? Like if I steal this and put it here, and then reassign to 25. We cannot. Can I just put an access? We cannot. Very interesting. What if I put a bunch of nodes in here? We cannot. Alrighty. So something is obviously very wrong. We can either bust out a debugger or kind of fumble around in the dark for a little bit. I feel like we should just bust out the debugger. So we're going to sadly bust out some proprietary debugger. because we are on Windows. Alrighty. Arusia says variable name too long. Kappa. That's definitely it. Our variable names are just too long. And it's causing all sorts of issues in Windows. Alrighty. We're nearly here. I don't need that. Any other breakpoints? I don't think so. Okay, now I'm going to learn from my mistakes and point it to the proper file to compile. And then we will run this bad boy. And hopefully we'll get an exception in C, because this is Windows. And it's got weird, yep, exception thrown in C. Look at us. Expression children next child was null pointer. What do you know? So in Cogen, we have what? Generate code to copy last expression result register to if result register. Generate then expression body. So we're in a node type if. I can't look at it in here. This is killing me. So in cogen.c, node type if, Lander says the English naming New York, colonizer 1. So the Dutch called it New Amsterdam, right? Colonizer 2. Yeah, colonizer 1. What's a similar city to Amsterdam in England? London? Colonizer 1. No, that's not right. What about York? A city with 200,000 famous people for pretty much nothing. Exactly. We're like, we can name it anything. This is our first, we're calling it New York. It's like, we screwed that up even. So it seems like expression equals expression children next. What is this? So we have an expression which is an if. So can you show me an if? Can you like print node expression, right? That's all I need. Exit for me. So we have if children next child right, next child. So expression children next child, but then next child you're going to get to null. So I should say, oh Christ. Basically we should have a macro to check for things like this, but this is fine for now. If expression children next child. So just to picture that, if expression children next child. If we have an empty body, will next child even be a thing? Oh man, we got some things to worry about. So if not this, can we just break? Otherwise, no, we have to do this stuff either way. We have to basically say if we have an otherwise, do the otherwise thing. Otherwise, don't do that thing. So this is just gonna say, why do we say last expression? What is this? See, this is all part of the otherwise, but we need after otherwise label, don't we? Yeah. So we need this stuff generated kind of no matter what. We just don't want to do this whole dereference if this is null. Okie dokie. Generate code to copy last expression result register to if result register. But we set last expression to null. So we only need to do this if last expression is non-null. I'm going to do it this way. And if last expression is non-null, that would mean this while happened, or this if happened, I mean, this one. And then I also, because if expression is null, we don't do this, then that means that last expression actually may not be updated. So we still have to say, if we have the data we need, go for it. Okay. I think this is fine. I don't think I need to say generate code too. I'm just going to say copy last expression result register to if result register. So after the body of an otherwise, we'll copy the result of the last expression in the otherwise to the result of the if register. We're going to have to do some type checking to make sure this all works, but it's fine. And then no matter what, we print the after otherwise label. That way we can jump to it after our if condition and stuff. So effectively, there's always going to be a then. Hey, look, that's much better. It didn't crash, folks. We're now not cogenning requiring an otherwise body. This is nice. Look at us. We should probably commit, because I forgot to do that today, by the way. We're going to do some git the commit, everybody. Grammar to Parses Boy says, in Germany there is an interesting myth. People say that there was a vote for the official language for the US, English against German, and German lost by 1 vote. So unbelievable that people think that's true. Right? Nobody here is German. Everybody is like British people that didn't like the British, right? As far as that's what I've been told in my history classes. I don't think they're right, but that's what I've been told. So we're gonna have a lot of things to do here. What is this within? Can I go check out this type checker? Function calls. Yeah, we'll do that. Fix type checking of function calls. That's a good first step. Okay. Fix type checking. We'll say type checking. Fix function calls. They were broken ever since we changed function parameter parsing to use variable declarations, right, instead of manually parsing. Oh, wait, we didn't fix function calls yet. That's right. I remember now. I figured, yeah, it's fine. Well, this is fine. Everything is fine. So, yeah, that's pretty good. They were broken ever since we changed function parameter parsing to manually parsing each param. I think that's good enough. Now, parser.h. Yeah, hey look, this is the stupid context bug that was causing all sorts of issues. So we could definitely fix that without really altering much at all. So this is going to be a parser. What is this? Kramer says, I am so an idiot. I am wondering why an implicit cast doesn't work, but I have not called my initializer function. Ooh. Ooh. I always hate when I do stuff like that. It's like you get so focused on the internals of the project that you forget, like, oh yeah, I'm calling the C++ compiler and not the C one. It's like, ah, darn. There's always those little bits that you just miss, and it feels so bad when you finally figure them out. But it also feels good. It's like a relief. Fix silly parse in context. I should do that. Parsing context error. we were adding children to both the head and the tail of the linked list, which is just insanely silly. Perfect. Okay, we don't need to commit printf output. We changed if to if condition. That doesn't really matter. What did we change? Here it is. Hey, we committed the fix for the problem before we committed the actual cause of the problem. Look at us. So if we have defun params and defun body, so this would be function parsing changing. So handle stack operator. Sure, get an empty line, why not? I'm sure it helps. And where else? Handle function parsing. So defun. I would assume that's where this is. Yep, that's in defun. So instead of creating a parameter list and doing that whole thing with a forever loop, we just create a stat. I think this makes sense. Oh man, this removes a lot. So do we use parse type at all in our staged right now? So if I do Control S and look for parse type, staged changes. See, we do use parse type in defun param, so we're going to need parse type at least, which means we're going to need the header with parse type. We're going to need what? The implementation of parse type, which is here. Perfect. Okay, so we should now have parse type header and parse type implementation. We have function parsing update. You can remove that from there for sure. LandoXD says, oops, I'm back after accidentally disabling my internet and wondering why it broke. Lamau. At least you don't have your internet disabled and have to wonder why you're broke. Right? Grammar 2 Parser Boy says, yeah, it works. Awesome. On variable definitions. For function calls, I need to refactor my function matching algorithm. Otherwise, it will be impossible to work with implicit casts. Yeah, I have a fear that my type system is very similar. RPWH says, yeehaw! How's it going, RPWH? Thank you for tuning in. How's it going? Also, I missed a follow 20 minutes ago. Enumerate _ Thank you for the follow. Thank you for lurking in that background. We enjoy your presence greatly. Okay, so we set the function in the thing. We parse the type and type the parse. Perfect, perfect, perfect. So what are we doing here? We create a variable declaration pointer just so that it's named and kind of makes sense what we're doing with it. And then we also, we also just use the type parsed from above. Definitely get rid of that random error. Okay, I think this is good. RPWH says, I'm good, thanks. Just about to start the advent of code problems. Ooh, to consolidate my Rust learning. Nice. That's definitely a good way to go about it. LanderXT says, you just missed a follow? To the guillotine! Oh wait, I'm British, not French. Oof. So you're just gonna, like, shoot me with a musket, or... You're gonna hang me. That's what you guys do. You hang everybody. That's right. You got, like, the big lynchers, and you would all go and watch the people die. That's right. America did that too, to be fair. Okay, so I think pretty much everywhere does that. Mr. Mugume says, what the Brits do. RPWH says shake our fingers at you. That's right. You are being very impolite, young man. We just get very annoyed at you. That's right. A lifetime of annoyance. So this is going to be parser. Use parsing stack. Oh god. Parsing stack to handle function, parameter, and body. Before, we manually parsed function parameters, which caused a lot of, code duplication. Fixed now, haha. Alright, what else do we have? We have if renamed to if condition. Sure. And we have an updated, a slightly updated. I'd say we're still working on the if, but we'll stage it for, well, we'll not. We'll do some things from, yes, unstage all. We did implement that. Is that used anywhere? Do we actually use environment set end anywhere? Right? I'm very curious. Can I do this? Probably have to do that. It's used by the function parsing, so I probably missed that in a commit as a dependency. Which one? Probably the last one, so we're just going to do a fixed commit. This is why you look through all of your unstaged changes before making commits, by the way, instead of doing like I do. Be smarter, not harder. No, it's work smarter, not harder. That's right. So we will do our little if condition changes that don't matter, just to include them, since this is a fix commit anyway. Right? We'll do our little fixes. And in Cogen, we'll make that its own commit. That doesn't need to be fixed. These are just little bits of issues. What is this for Cogen? Expression children next chat. So this is the changes we made to make function calls work again. So we should definitely also include this, which is our fix, right? We gotta get our fix, man. I gotta get my fix. We can do this little fix. We're just gonna include everything. My Git workflow is called just send it. Oh my god. You scare me. What is this for? This is variable reassignment. I remember we redid this yesterday. We'll make that its own commit because that doesn't have to do with what we're doing right now. But for function body, this is probably important. I would say this is important. And then this is important. Okay. So effectively, where are we at? We are in here. Yes, I know. So that's a variable access. Did you know that the word bank comes from the Italian table and bankrupt comes from Italian broken table? That's really funny. I did not. That's kind of odd. Is there a reason? What is this? This looks relevant. Cogen program for global variables. Type, if not environment. Oh yeah, so this is for pointers and stuff. We did not properly get the commit at all. We did this very messily. So now these are our staged changes. So now in the parser, we just have comments. In the Cogen, we have little fixes to symbol to address. Yes. We have the same thing. If not context, variable symbol. So this is just an extra error message. It doesn't really matter or do anything. We can put that in at any time. It was only, we don't hit it unless we mess up our development. So it's really only for us. Lander says, I'm going to pretend to be a debt collector, enter someone's house, break their table, and declare, you now have a bankrupt. Lamau. Error equals parse get type. Instead of error equals parse get type. I'm confused. What changed here? We just commented out the print node and says this following line causes errors when it really shouldn't. I don't think it does cause errors when it really shouldn't. Is that in Cogen? Yeah, I'm just gonna get rid of this confusingness. Make that a little more easy to understand. Remove print node. We're gonna remove print node. Why not? This is its own thing. Comments, empty line. Okay. Now, the thing is, this commit is actually a part of the last one. So we're just gonna say fix like that. And then we're gonna do an interactive rebase. We're gonna base back just to one commit back. We're gonna, I think, cherry pick and then squash. So we're gonna cherry pick and then squash, and then we're going to, use UTF-8 to display. And then both of our commits should now be merged over here. And we can say this is a combination of two commits. So parser, use parsing stack to handle function, parameter, and body. Before we manually part, which caused a lot of fixed now. This required changes to type checking and Cogen. I think that's it. We're just gonna add that. So now we set our message, and back in one commit, we have all of our changes. Hooray. Okay, now we can do, what is this? Comment. We have some comment, but also an error. We don't need either of those. We'll take original context. We will take variable reassignment, everything we redid there. Okay. We will take our little symbol instead of label buffer fixes. We'll take our to-do and stuff, but not our dumb little comment there, which doesn't really help anybody at all. We'll use the proper preprocessor definition. So, dumb comment. Oh, there's a cat here. Yay! I'll be right back, chat. I know, kitty. Oh, perfect. Sorry about that, chat. Cats. So these are all comments, and yeah, in the parser, those are comments. So we now just have Cogen, small fixes. Symbol to address, used the wrong length specifier. Length preprocessor definition, directive. So that has been fixed. What else? Show me your ways. Along with other minute changes. Did we change any I guess variable reassignment has been redone from scratch and is much more concise, I would say. Concise and easier on the eyeballs. Perfect. Okay. And we are now ready to push. Grammar to Parser Boy says, the first Monex exchanges were on simple tables on the street, so if you don't have money to operate with, your table was broken. I see. Grammar says, yeah, I really like to know useless stuff. It's not useless, it's just little interesting small facts. So we will push, our local main branch, to the origin. And GitHub will now have all of our updates. So hopefully this fixes some things. But we still have things to work on, because this didn't error. The global scope, this is a global variable. I don't know if this would make any sense, because what if this happens? How does this work? This, you know what I mean? Do you see what I'm saying? Like this doesn't make sense. But this works. See, it's fine. So this little issue is kind of the cause of our problems with our if statements, at least one of them. And what we would like is for some number, if it's declared in the if body, to not be accessible outside of it. Which is annoying because it means that this means that we're going to have to create a context for each if and else. But if there's no else, we're only going to create one context, which means, well, okay. Yeah, this is going to be a whole thing. Invalid syntax, unknown symbol. What's your unknown? Oh, some other number. I didn't get rid of that. I was like, what? So this would work just fine. And it shouldn't. So this shouldn't work. But it does. So we need to create in the parser a new context when we reach an if-then body, which is only possible through here. We also allow for empty bodies, which would kind of throw everything off whack, right? So to do /fix me, this branch of control flow kind of breaks contexts. We'll think about that in a bit. Okay. This is going well. We're making some progress today. We're fixing bugs. We're cleaning up the code base. And yeah, making new progress with contexts. If context. So we basically have to just do this, right? Parse context create. Done, right? It seems like it's that simple. How do we deal with a defun body, right? That would be something to think about. Defun params. We just say, I guess for a function, when we're doing the parameters, we need to be in the context. So that would be handled down at defun. Also, this isn't used anymore. Whoops. That's still there. He ain't gonna be in Rush Hour 3. All right. So when we create an if condition, I don't think that the if condition should be in the if context. I don't think that is needed. Because that would mean... Okay. I don't know when this would ever be useful. Should we have a variable declaration in the condition be accessible after? The semantics of creating a language. Okay, so if we put a variable declaration inside, like it doesn't even need initialization. If we put a variable declaration inside of an if condition, should that variable be global or not? Like part of the parent scope or part of the if scope? Because if it's part of the parent scope or the if scope, we can access it within. But if it's part of the parent, we can access it after. I'd say, I don't know. Because an if scope is really just going to be, oh man, it's going to be a whole thing. This is going to be a whole thing. I'm not going to think about that right now. We're just going to worry about the fact that we need to create a context. So let's just create our context here instead of where we did up above. So then we can say, I think it was star context equals. There can't be too many of these. Okay. So in parsing the if, we go, okay, we're done. I'm going to put a question mark because I don't even know. First check for else. That's a big to do as well. But we can say star context equals star context parent. So this will eat our context effectively and exit. So we need to do this also in the if then body handler when we are done here. And also we need to create a new to do create new context for else body. If else Bobby. Grammar to Parser Boy says, I have leaked my code for implicit casts at Discord. Ooh, let's go check it out. Lander said case 1. Nothing. Classic. A really nice way to implement implicit casts. You can also make custom types implicit castable. Nice. Yeah. That's exactly what I pictured. That's perfect. So you can do an interface with... Is this an interface or a generic type? So this is a generic diction. This is a dictionary, which is generic typed. But you have an interface on each side. That's cool. I like how you do this. I like how you do this. I see what you're doing now. So you have an array of interfaces on one side, so you can just create a new heap allocated array in C# like this, apparently. Very cool. Yeah, so a U16 can be anything bigger than it. A U32 can be anything. This is very cool. That's really nice. I like having all that data in one spot and just easy to read, and like it's so easy. It's almost JSON, right? When you get things almost to the JSON level, you know you're doing it right. You're like, okay, this is data. That's a really cool Grammar to Parser Boy. Thank you so much for sharing. It's so cool to see your language progress. And it's so much more mature than mine. And has much less memory leaks, I would imagine. Okay, so if we find the close, Greber says there's also a second image. Oh my god, I missed it. It tricked me. I thought it was just that same thing because it says has implicit, and I was like, oh yeah, makes sense. But that makes a lot of sense. So it has implicit cast operator of type and type to cast to. Try get operator type implicit outvar method and type return result and method return parameter type equals to cast. Nice. So you check a valid typecast by getting the type within the list, the implicit list based on your type. That's very cool. That is very cool. I like how simple it is, but also how complex. You're like accessing a hash map by an ID, returning it, and then using it as a comparator. That's very cool. Very, very cool. But yeah, Grammar to Parser Boy, thank you so much for sharing. That's very, very interesting. So when we create an if-else body, the idea is we'd have to create a context somehow here. Let's just see what we get currently, because we're going to break things. Symbol, some number. Invalid syntax, unknown symbol. Lander XT says, I'm going to disappear for 30 minutes-ish. All right, Lander, we'll see you when you get back. We should still be live. Grammar to Parser Boy says, no, this looks for a method in a type called implicit. This is the logic for finding the correct method to make custom types implicit castable. The method. So I see you write into method here. So method is probably like a member of some interface. iMethod? I don't know. Because method isn't in this list. So is assignable to type, and you say if they're equal, of course it works. Else, if has implicit cast operator, type into cast, return true. Yeah, it seems like this checks for validity of implicit casts, right? Because it's a Boolean. But maybe method is being written to somewhere, and then that's used when this returns true. I see, I see. That's very cool. That's, yeah, too complicated to share on a simple image. Absolutely. Absolutely. So much going on. So now we are saying, hey, we're in the wrong context, buddy butto. You can't do that. So we have fixed our little issue. But we haven't fixed this issue, I don't think. See, we're still able to access the same variables from the if within the else. This symbol is for this one. And there's a problem with that. So creating a new context for if-else body, what should we do? I think we should say context equals context parent. And then we have to say, basically add child once more to our context and set it to basically a new, how did we do this before? I guess we should do parse context create. Yeah, so this makes sense. Eat our, okay, we can just do this here. Eat the if context. Because we have handled it. That's what that means. We've handled it. The then body has been handled if we find the closing brace. But if there's an else, we want to create a new context for it to parse into. And then when the else is done, we can just say eat your own context, please. Type is not found in environment. That's a yikes. That's not good. Where's that from? Code 1, type not found equal. Type not found equal? It's a reassignment. What the fuck? What'd we do? I don't know what we broke, but it's pretty funny. Type not found equal. So what is happening now for if else? Maybe if else has some invalid setup. So we set our context to a new context. So our context, we eat the if-then body context. We're in global context now, we know, in this specific case. So we're in global context then. But then we find an else and everything valid. And we go, oh, create a new context with blackjack and hookers, right? So we create a new context. We create our if-else body, which has a first expression. We set our stack body next child. So we do use the stack body right here. So we set stack body next child to the if-else body. To do, don't leak the operator, whatever. We set stack body to if-else body, stack result, blah. So stack body would only be used if we have an if-else else, which isn't possible, but when we have else if, it will be needed. So technically this isn't needed, but the thing above is. Okie dokie. So when we run it, our issue is type is not found in environment. So where actually is that? Type is not found in environment. It's in parser.c, okay. And it's in parse get type. Okay. So when we parse get type, we have this wonderful little debug that we can just print out, right? Searching following context for symbol integer. It doesn't print out the following context at all. Why does environment print not print out anything? I don't know. So I know why. So we'd have to print all parent contexts, which would kind of be a thing. You'd have to say like while context and kind of do this whole thing. And so I guess we could do like searching these contexts for that thing, right? Definitely don't need that. So searching following contexts for symbol integer. We have function, which is a function, searching following context for symbol equals. See, why are we searching for equals and then erroring? So there's a place where in a reassignment, I would presume. I'm just going to put all this back, by the way. So a reassignment, we expect an equals specifically, right? Yes. Okay, let's think about what this says. So we have a variable access, and we look ahead for variable reassignment here. I guess all of here is a variable reassignment. Else we look for a declaration. So are you telling me that this isn't working? Why are we expecting a type? Why are we getting here? This says else. Else what? If none p, var binding. Okay. Not none p, which is parse get variable. Okay. I'm starting to get it now. So type is not found in environment equals because this symbol is not a valid variable, right? That's not a valid variable, and we're trying to do a reassignment. So let's search for that error specifically, right? I feel like we should, this is easy to fix. When we're parsing a declaration, which I think is what we're trying to do, but it's saying type is not found in environment because equal is not a type, because it thinks this is a declaration, and because it's not a variable access, it's not a valid reassignment, so we never checked for it. But we can check for it and say, reassignment of something that is not a variable is not allowed. So this is a little bit of a negative parse. Grammar2Parser says, I have similar error message. Function #unit not found, but I don't want to fix it today. Exactly. There's so many error messages that some of them you just got to push off and be, tomorrow. I'll deal with that tomorrow. So this is an error of syntax. Well, yeah, sure, syntax. Why not? Reassignment of variable that has not been declared in scope is not allowed. I guess we'll just do the same thing pretty much. Reassignment of undeclared variable, undeclared variable that has not been declared in current scope. It's not in current scope, but it's in current or parent scope. In accessible scope. I like that. Reassignment of undeclared variable in accessible scope is not allowed. See, I feel like the scope thing just makes it confusing. We're just going to say that. Can we print which variable? We can. We'll say invalid variable symbol. And this is going to be symbol, value symbol. So now, reassignment of undeclared variable is not allowed. Invalid syntax. And if we didn't have -v on, this wouldn't happen. So if we take the -v out, for example, you see we get invalid variable symbol, some number, invalid syntax. Reassignment of undeclared variable is not allowed. Perfect. So now it's saying some number does not exist. It can be something else. So you could have some other number here. And then we have symbol, some number, invalid syntax, unknown symbol. Because we tried to do a variable access on something that isn't anything. Awesome. We now have a much better handling of scopes in if and else, at least from the parser side. This shouldn't work, and it no longer does. Haha. Alrighty. So we fixed it with this error and some changes to parsing of if and else. So we have comment, We fixed that it no longer breaks contexts because of this. We should definitely check for an else after an empty if body. So definitely something still to do there. We can remove is this needed and should new parsing context be created? It should, and it has. Eat if then body context, and then create a new context for the else if it is found. in handle stack operator, this is if else body. Make sure that you eat the if else stack. This is unused stack operator. Create a stack for a new if statement. And handle that bug where an invalid variable tries to be reassigned and spit out a better error message. Well, that's pretty concise. That was a good commit. So we just have to say something like, show me the whole thing. Show me the Carfax. Parser. Update. Use contexts to handle if else body scopes. Environments. We'll use environments because that's what we use. Yeah, we'll do scopes. Scope sounds better. Use context to handle if else body scopes. We'll just say if and else body scopes. Why not? Before the bodies of conditional expressions were, I don't know how to say this, implanted in the parent scope. This means that variables declared in them were accessible outside of the body, which is non-intuitive. Especially for conditional expressions. Alrighty. We can commit, we can push it. How about that? Turn into coding. Alright, that looks pretty good. Perfect. Now we have the thing that was meant to error errors. So they now have scopes. Wonderful. This is going to be a whole thing during type checking and code gen, but we now have scopes. So let's make sure that we didn't break like basic conditionals. This should return 42. Conditional 1. We generate code, so let's check out code.s. And let's think about it. If move 1 into racks, test racks, jump of 0. Test does not set the 0 flag unless they are literally 0. So 1 will fail this test, so we will fall through. Move 42 into racks, move racks into R10. R10 is probably our result register of the entire if. So racks gets moved into R10, jump to L1, move R10 into racks, which is our function return value. If we had an otherwise, we would move 0 into R10. Why do we do this? This is just to initialize the result register in the case of an empty otherwise. So if otherwise is not empty, we don't need this. Let's actually go take a look at that. See, I think we only need to do this here. So this will make sure that if you have an otherwise, I guess this would be in the else. Right? Yeah. I think that's right. Yep, now we no longer have it. So what that's for is if you have an if with no else, you still need to set the result register of the if statement. So we set it to 0 in the case that the if goes to the else. Hopefully that makes sense. Axe, so great to see you. Thank you for tuning in. He says, missed a bit of progress here, but should this be the responsibility of parser? Isn't that semantic analysis? That is what parsing is? Semantic analysis? No? You take, because you lex things, and then say, now I have a list of tokens, and then you semantically analyze the list of tokens in the parser. Maybe I'm wrong. Maybe I misremember. I'm not professional. I am kid. But what were you talking about specifically that should be handled in the parser? Are you talking about like the redefinition of variable stuff? You're right, we could do like a whole separate pass. We could have the parser just build nodes and do nothing else, but it's really inefficient because the parser easily can tell in this exact scenario, this exact error is happening. There's no reason to let it through and then catch it later, you know what I mean? When all it requires is a little bit of handling in the parser. And once we update our nodes to contain our spans properly, which is really just going to be a lot of working with working result and stuff. We're going to have pretty good errors. It's going to tell you where in the source and print out some context for you to look at. But you are right. Our parser is definitely not just a parser. It's a very active part of our, like it does checks for variable redefinitions. It checks for invalid types in variable declarations. We could just leave that for a whole nother pass, but there's no reason to do another pass when you have the data in the AST. Like you already have iterated to that node effectively because you just built it. But yeah, we're definitely doing things non-conventionally. We're not like building a parser that goes into this stage, that goes into this stage. We kind of are just making things work, right? Because again, I'm just a kid. I'm not being hired to do this. Luckily, not being hired to do this. Alrighty. So I just have to check my phone. Okay, I'm ready to go again. Let's check it out. So, what issues do we have? I guess we don't really have issues. Let's try and run this program and make sure it returns the proper thing. So we're going to use as and generate an object file from this assembly. And we're going to use LD, and we're going to use LD to generate an executable from that object file. And then we're going to run the executable. Failed with code 42 and no output. That's perfect. That's what we wanted. If we put like 4 in here, recompile, rerun, failed with code 4. Look at us. So conditionals still work. They're not completely broken. They still work in Cogen, and we're probably doing very little type checking at all on them, so it doesn't really matter there. How nice. Okay, so type checking a function, we're gonna have to say last expression, and we're gonna have it equal null. We'll have it equal body expression at first. And then afterwards, we should say to do compare return type of function. Axay says traditionally parser is just responsible for generating the AST, which is then analyzed in another pass. But yes, it's a trade-off between maintainability and performance. I mean, I don't think it's less maintainable. A continuation-based parser is already hard enough to maintain with all the control flow, right? The fact that the parser is non-recursive and can catch a bunch of errors, I'd say is a positive. You know what I mean? I don't think there's a reason to like limit the job of the parser just to make it like more maintainable. Because I don't think anything here is different than a regular parser. There's just one section every once in a while. Like all this is just regular parsing. There must be valid, they're just syntax errors is most of what this is. But we get some different errors when like a variable declaration. There's no reason you can't handle it and say, hey, this has been redefined already. Because while you're parsing, there's no reason you can't build your contexts and your scopes, right? Kind of like C does. But you are correct. This is not a traditional parser. This is my parser. For fun. I'm not doing it for a job. I'm not even doing it so it works or so it's correct. I'm just doing it for fun. Compare return type of function to return type of last expression. Whoops. Last expression in the body. So we have last expression. And we're basically going to say if last expression, which hopefully we have a function with an empty body that returns something is a little sketch, but we'll get there. Empty body. Perfect. So during type checking, the last expression, we're probably just going to do something like this. And sure, is this the proper context? What context did we give it? I think it's called to enter. So it's called context to enter. And then we need to enter. Is that a pointer? I don't think that's right, but we'll get there. We have expression. So we would like last expression to be type checked, and this is into last type. That's right. It's like this. Oops. Okay. So the problem is these have to be dereferenced and addressed of. This returns an error. So we need to return that error if there is an error. Alrighty. Looks great to me. So now we can get the return type of the last expression in a function. And we would like to then get the expected type. So what's the return type, right? So the return type is going to be in what form do we need this? We need a node. So if I go to parser, go to parse get type, right? So parse get type will look under ID for the type in the thing. So I need to get the type ID and everything like that. Okay, so I'm going to have node pointer return type. I'm assuming like this. And I'm going to need to do something. Okay, so I'm going to need to get the ID. So maybe I'll say, okay, I know what to do. Return type ID, I'm going to need a pointer to, and the return type should be stored in the function AST, which we have. So we just need to say return type ID is equal to expression children, I think it's next child. And then say while return type ID does not equal, I guess return type ID type does not equal what? No type symbol? Is that what it would be? Because it's just a type symbol. I don't think it's anything specific. So while it does not equal symbol, then say return type ID is equal to return type ID children. This isn't perfect, but it will handle pointer types. Yep, still everything's working because we don't have any errors or issues. So return type ID, we're also not doing any function parsing. So maybe we'll do like simple function I guess we could go to math. Math had functions. It had lots of them. Simple math? It was in examples, and we did interesting math. That's what it was. So we need samples, not samples, examples / interesting math. Exited with code 5. Okay, that might be one that's a little too complicated right now then. We'll go back to simple. Simple func. Defun foo, x integer, returns an integer, and return x plus 25, 35, foo 34. Oh, still the wrong thing. Malformed or misshapen parsing context encountered during type checking. What do you know? So what do you think the issue is? We have x plus 35, so parsing looks like it's coming out great. This is all perfect. And you can see that we have symbol integer here. Oh boy. Okay, so we get the return type ID. We then have to do a type compare of return type and last type. If types are equal, return 1, otherwise 0. So if this equals 0, then we're going to return an error, which is a type error. Last expression in function does not match function return type. And we'll say return type of. Last expression in function does not match function return type. Problems. So now we have return type that we have to create because we have to use parse get type in our context to enter, I believe. And we have to look up our return type ID into return type. Okay, so now we have a return type for our function, and we have it in return type. Then we get our last type, and then we compare these two. So not really able to do that right now, but we still have malformed or misshapen. Where does that happen? Where does that happen? Oh god. Node type function call. So we have the function foo, right? Oh, so maybe in a function. Excuse me, function? Maybe I typed it wrong. So for every body expression, we type check it in the function context. Right? Shouldn't we update context to enter? Oh, we do. We do right here. So by doing this, I mean, it should work. I'm not sure what we're not finding. So malformed or misshapen parsing context. This is within a function call. And with the function call, we're saying get the expected parameter type. Is that correct? So what is temp node children? What is temp node? Temp node is a, here, we can just print this out. Looks like we've done this before. Temp node is a variable declaration of x. So temp node children is the symbol x. So we try to environment get from context the symbol x, which seems like we should get it because it's right here. You know what I'm saying? We have the variable x, which is an integer, in the function foo context. but we have malformed or misshapen context encountered. So what context are we in with the function call? We're in the global context, right? But we don't have any, the function call is calling 34. So okay, so the function, this is what we were running into yesterday that we didn't fix. We talked about this in the git commit earlier. This is the problem that the function AST does not store the type of each parameter, which means for a function call where all we have is the function AST in value, right? So value is our function. We don't actually know the types of the parameters, and we're trying to look up the types of the parameters in the environment where the function call is being made, which will definitely never work. So this is wrong. So what oh man, you know all that stuff we just changed? You ready to change it back? No, it's not like that, but it's like that. So in defun params, also I'm tempted to just do this with lambdas. We do not handle lambdas properly, and that's a fact. So we should probably just delete them for now from the language. But they're staying. They're staying. Continue at your own risk. So you know when we would normally just do this thing like continue? Yeah, we can't just do that. Because here's the thing. When we parse a variable declaration, we do need to do that actually. Remember when you were talking about a traditional parser? You ready to like cringe? We're doing some more semantic analysis. If I could speak, it would be funnier, I'm sure. So when we are Lamau. So when we are parsing parameters, all we have to do, I say all we have to do, so we can either parse parameters manually, which would kind of be odd. It would mean that we don't reuse any of the parsing code, and we just basically stay in here forever in the stack operator, which I don't think is the way to do things. So I think we're going to add a new child to the function AST. That's right, chat. But you didn't see that coming. I'm popping one out. We're having a new child. Right? So this is no longer this. Parameter names. And these are going to be like var decals, right? I think that's fair. So any amount of variable declarations for parameter names. Then we'll have parameter types, which is literally just type symbol. Or pointer, right? Or something like this. Pointer to symbol of integer. Stuff like this. Okay, then we have return type symbol, which again is like this. Parameter types, return type. We won't say symbol. We'll just say type. It's kind of implied. Okay. I don't think this is too insane. Does anybody else think it's too insane? This may be too insane. Because building two lists at the same time seems kind of dumb. You know what I mean? It seems like it would be kind of hard to deal with that. How else could we deal with this? We could also just have what we had before. and deal with, like, each one of these has more things, right? So we could also, we could do this. We could have parameters, and each one of these would be a parameter. So maybe we would have like a var decal, and then as a child, it would have its type, like have a special. I think the one is just confusing things. So have a var decal with like a type symbol. I think that's not too insane, and it wouldn't require that much reworking, so I think we're going to go with that one. So each time we parse a parameter, so working result should be that parameter. So we can say if working result type does not equal node type variable declaration, return, I don't know, error syntax, I would guess. So return error after prepping error syntax. And say function parameter must be variable declaration expression. This is terrible and not a good error message, so we should fix that, which we will. So now we know that working result is a var decal. Now we just have to look up var decal symbol in environment, right? Because our current environment, we are within the parsing of the context, so our current environment will contain what we need. And then, because the variable declaration will set it. Yes, yes. So now we just need to look up the var decal symbol in the environment to get its type symbol node thing. So, look up var decal symbol. So working result should hopefully be a var decal symbol. So we're going to use environment get to get from what environment? Our context, we're going to need to get from that in the variables environment. Thank you. Autocomplete did not help me out there. And we would like to get our working result into, what do we have? This is going to be our type. I don't even know what to, sure. This is awful. I know this is awful. So now, if this equals 0, we're just going to say we failed. Error generic. And we're going to say could not find variable type in context. Sure. We'll hit that error one day and be very confused. We'll do a grep and we'll find it right here and we'll go, oh yeah, that makes a lot of sense why this errors. I promise. So with the type, we should now just say add a child to the working result. Maybe we'll do stack result here in case we, well no, working result should be a var decal. If it's not a var decal, we should have a type error, so it doesn't really matter. Or a syntax error, depending on how you look at it. So we would like to add a child to our working result, var type. So now, we have a variable declaration of symbol x. Should we not have a variable declaration of symbol x of with the type? Why is the type not here? How dare thee? Excuse? So in handling defun params, we don't find the end of the parameter list. So we say, okay, if working result does not equal a variable declaration, spit out an error. But it's not spitting out an error. This isn't spitting out an error. So it's like we're getting the type and adding the child, just never actually doing it. It doesn't make sense, right? So we're going to print node working result is what we're going to do. And then we're just going to exit to make it easy on ourselves. We never get here. Isn't that comforting? How'd we never get here? Simple fun. This has a parameter. I see, but after the first parameter, we just end. So we're following all this code control flow rather than this way. So this needs to happen above all this stuff. Simple. I get it now. Could not find variable type in context. Interesting. So let's see, what did we do? We're looking up. We're not doing that apparently. We're probably failing here. I don't know. We could probably use parse get variable, right? In our current context with our working results into type. Does that return error? I think that's fine. Variable is not found in environment. Well, there you go. So the problem with that is what? So when we enter a function body, so we don't create the environment. We're already in the context, it seems at least. So if we look up defun params, you can see that when we actually set defun params, we have already created a context for the function. Interesting. So while already creating the context for the function, we parse defun param. So if it's a variable declaration, our current context, right, will be equal to the new context in the function, and it will be into there. And then we will parse handle stack operator, and we pass it our stack, and up into defun params, we then say, hey, our stack and our context, let us use that, please, but it doesn't. So let's print out our working result. Right? We're going to do this way higher because we're hitting errors. We get a variable declaration with the symbol X as a child. Right. So what we would like to do is add the type of X as a child to the variable declaration, which is not how we normally do things, but for parameters, I think it's the way to go. So variable declaration of the symbol X. Key. So we say if working result type is not a variable declaration, say, hey, you screwed up. I think that's valid, and I don't think that will cause issues. And that's correct. The issue comes when trying to do this thing. It says variable is not found in environment because I have to do this. There we go. So now, for variable declarations in function parameters, we have symbol x, symbol integer. And this would be a pointer to an integer if it was a pointer to an integer, right? Also, I can use unmode for some syntax highlighting. So if it's a pointer to an integer, you can see that, there we go. That's what we have. All right, that was a lot of work just to get to the simple fact of we don't have what we need. So temp node children next child should pertain to our type symbol. So return type, expected type of parameter from temp node. So this really should say expected type of parameter found in temp node children next child. That looks good to me. So then we just have to compare our expected type to our return type of our given parameter. Invalid arguments. Not enough arguments passed a function. But there is 1, 1. So what happened? Temp node equals temp node next child. Iterator equals iterator next child. That should be fine. So function children children. Function children children, which means temp node is this var decal. Iterator is expression children next child children. So expression children next child children. So this is the first parameter and the first parameter. While both of them get the return type into type and get the return type of what? Of iterator, and iterator is equal to our function call. So get the return type of integer 34. Did not mean to click on that like that. Which is just integer. This returns an integer. It's an integer. Integer, integer. So the return type will just be integer. So when we type compare temp node children next child, which is temp node children next child, the symbol integer, with type, which I hope is the symbol integer. How does type compare work? Type probably doesn't work on symbol types. You know what I mean? Where is type compare? It's probably right above. Yeah, see, type compare does literal type comparisons. So to resolve the type symbol, we're going to need to resolve the type symbol effectively. Is that what I'm seeing? Or not resolve the type symbol, but we can't do that because it's an expression return type that we're comparing. So effectively, we can get the return type of the given parameter. Nexovec, thank you so much for the follow 6 minutes ago. I very much appreciate it. And thank you for joining our amazing club. I've been streaming for nearly 2 hours now. Be sure to check out the Discord in the About section down below. We have a ton of fun. Lots of fun. We'll wave at you if you show up. I make announcements every time I go live, so you'll never miss another stream. You can get code review. There's all sorts of things you can do. Be sure to check out the YouTube down below in the About section as well, which has all my previous broadcasts. You can see all 3 days of work we've put into this compiler. Like actual literally 72 hours, not just 3 days consecutively. And then there is also the PayPal donate button in the About section. I would greatly appreciate any and all donations that come in. If you leave a message, I'll read it on stream as long as it's appropriate. And if you leave your name, I'll attribute it to you. That's my little spiel done. Let us continue. So we can get the return type of given, we can get our expected, but our expected type symbol is found here. So, hey, first time chat from a new viewer, Nexovec. Hello, okay, I will join the Discord. Awesome, we are ready to wave. I'm ready. I'm ready. Nexovec says you don't need to run a whole ad panel on me. It wasn't just for you, it's just because we've been streaming over 2 hours, Nexovec. I didn't mean to say all that directly to you, but I probably said it right after saying your name. So that's my bad. Lolo. When I looked over, I saw that you had followed and how long I was streaming, so both of those things were in my mind. I didn't mean to, like, force you. Hey, it's Nexovec. We're ready. We've waved. How's it going, Nexovec? It's so good to have you. We hope you brought pizza. Lolo. Welcome, welcome. It's so good to have you. Alrighty. Alrighty. So we have our type symbol. So now we have to parse get type from our context into that, into results. Then we'll say results. Hey, I think we did it. I think we just type checked. We don't really have other types yet, so this becomes an issue, but I think we can do a silly thing like this. Not enough arguments passed a function. Well, that's not exactly correct. I'm not sure how we got there. We got a variable access bar. How do we get invalid arguments? Because that means we got here. Not enough arguments passed a function. Which means that what? Temp node is not null. Which means that what? We were expecting a parameter, but we didn't get it because iterator had a next child. Why would iterator have a next child? It doesn't. Iterator is here. No next child. Variable accuracy here, no next child. We should iterate through both of these linked lists equally. It doesn't make sense. Nexovec says pizza is here. It has a pineapple. Ooh, that's the best pizza. Hawaiian pizza is so good. Pizza time. Hey. Pizza time. Okay, so this should be a type error. So what's the type of, because we get function is our type, right? Bar is a function. So foo of bar should not work. Symbol x is an integer. Nexovec says, I made a parser for a language some time ago. Never gotten back to make an actual language. Hope I will learn. It's definitely a lot. It's not a small project. So I understand why so many people are able to start, but finishing it is actually that much harder, right? It's pretty crazy. But yeah, I'd say we've just gotten started on this compiler. But it does work. We have function calls and pointers and variables and integers and type checking. We're getting there. We don't have correct any of those things yet, but we're doing them. So you're gonna have to print me out what temp node is if it's not null. You know what I mean? So I'm gonna say extra argument. Sure. So we have an extra argument of a variable declaration, symbol x, and integer. Well, that doesn't make sense. So we should say expected argument, symbol x, which is an integer. So how is iterator not being set correctly? Whoa. Just alt-tabbed out of Emacs on accident. Woo. That's really cool to hear though, Nexovec, that you've made a parser. I would venture to say most people have not made a parser. Expression. Children. Next child. Children. Variable access bar. So if I were to print iterator, see we have something. This is confusing. So both of these things are non-null, but we still broke. Oh, I know what it is. I know what it is. We break out of the while loop, not out of the switch case. Huh. In that case, I feel like we should just return error. It really doesn't matter. We're just going to return error. I'm not worrying about it. Mismatch types. Hey, look, we did it. Argument type does not match declared parameter type. That's true. Bar is a function, x is an integer. What do we and we print out nothing to help with that. We print out which function. We should probably also print out something like invalid argument and expected argument. Expected. There we go. Now we're going to need like a print node, temp node 2. One of these is going to be iterator. So iterator refers to our given argument. This temp node refers to the expected. So invalid argument, variable access bar. Expected argument, variable declaration x, which is an integer. We could like deal with the types directly here. Invalid argument and type. We could do invalid argument and type. We'll try it. What does this look like? Iterator, yep, is in type. Invalid argument and type. Variable access bar, function, intate. I don't know. I think that's going a little overboard. I think this is fine. Invalid argument. Perfect, perfect. So now our compiler is saying, hey, function foo, invalid argument, variable access bar, expected argument, x, which is an integer. Mismatch types, argument type does not match declared parameter type, which if we fix, then works. Look at us. So I'm going to add something to the to-do. I want the compiler to be able to know when an uninitialized variable is being used. So let's just add that into the to-do. We did it, by the way. We finished parsing. I would say we started creating contexts and popping them when done. This means if else bodies, expression bodies, can now have their own scope. Woohoo! We did it. Put it to done, put it to the bottom of the list. So in typechecker.c, look what we did. We fixed around line 300. So we did our other to-do as well. Doesn't that feel good? We now have a custom variable declaration child layout specifically for function parameters, so they can be type checked. Learning function calls. Whew. Long-winded, but that's what we did. We are now done, and we can move that to the bottom. And then we had a miscellaneous. What were we working on? Oh yeah, uninitialized compiler recognizes use of uninitialized variables. Could even not allow use of uninitialized pointers, and also warn on other uninitialized uses. Perfect. Woo! That was a lot of typing. I feel like I had a machine gun in my ears. I see, yeah. I see in the Discord we have some stuff. Looks complicated, probably means it's good. Lamau. Waffle, you're funny. I don't know C#, Java, whatever that lang is. This is C#. 99% sure that's C#. Yee. I haven't gotten to the compiling part of my compiler. That's such a good sentence. I haven't gotten to the compiling part of my compiler, but I'll definitely get there. But I'll definitely solve semantics like implicit casts in the AST to IR part. Uh-oh. That scares me. Well, then it's not a compiler yet. It's gonna be. It's true. Also, I am the only one in this Discord not actively working on a compiler. Metal. That's how you know you're a rock star, Landar. That's how you know. I'm not actively working on mine. It's like a project I sometimes do. Yee. It's C#, Lamau. Looked like it. Public static void. All the keywords. My compiler source is much messier than this. Lamau. Oh, Nexovec almost made it on stream. So awesome. Great to see you all. Oh! It's happening. I'll let it happen. And it's gone. I'm gonna alt tab. Nexovec. You got one chance. Okay, this is taking too long. I got alt tab. I had time to drink water, stall, and drink more water. So good. Let's do it. Okay, so we now have proper type checking of function calls. That's nice. We should probably do some get and commit. Oh, I wish I was less dumb. So we have a var decal with a var symbol and type symbol. We should make that clear in parser.h. Name symbol and type symbol. Perfect. Good enough for me. In the parser, we do just this little bit to deal with it. Nothing too hard. And then, yeah. I think this is actually the code. And this is something else. Return type of functions or something. Also, did I miss something? I feel like I missed something. Why is Cogen? I feel like we already should have committed that. Why didn't we commit that? I guess we just didn't do it in time. Or we probably did it right after committing. We'll include that at some point. We're done there, and in type checker, yeah. So this is fix type checking. Fix what? Fix function call type checking. Fix function call not having all the data. Because function calls didn't know which context to look up the variable declaration of the parameter within. Okay, now we're just going to include these two little blurbs, moving the fprintf And then we're going to include this type checker blurb, and we're going to call this type checking. Negvorsa says, hi everyone. Hey Negvorsa, how's it going? We're just winding down the stream now. We're about to end today. No long stream or anything. But it is so good to have you in, Negvorsa. Thank you for tuning in. You're always so helpful. So for type checking, we would like to ensure return type of function matches returned type. That's valid. Also, make small optimization in Cogen for if else. For the otherwise section, for the otherwise body of code. Why? It does not need to set result register to 0 unless the otherwise body does not exist. Good enough for me. All right, we are now going to push. And we have get a commit. Look at us. We're much better than we were at the start of today. So now we can compile this program, and it even generates assembly in GNU assembly syntax, assembler syntax, something like that. And you can see it's pretty simple. We have a global variable bar, which is 8 bytes. We have a function foo. Here, we can do that. We have a function foo, which is just a basic function, which does a binary operator plus of x and 35. Then we have main, which is a function, I would say, is what that means. It has a variable reassignment of 34. So shouldn't this be variable declaration? Why is this here? In any case, we move 34 into racks into bar. So we reassign bar to 34. We push racks just to save it. Otherwise, you get some issues with function calls every once in a while. But we push racks, variable access bar, we move bar into racks, we push racks. So this is the actual pushed variable, like the value of bar is in racks, so then we push racks onto the stack, and then the stack contains the variable parameter, like the value of the parameter in foo, because then foo can use 16 off of the base pointer and access that local variable, which is how it moves into racks, adds 35, etc. That looks correct. Let's do our little incantation to get this thing running. And it failed with code 69. Hey, and if you'll notice, 69 is in almost for sure 34 plus 35. We can now do all of these and type checked, and like if this is a function, I'm pretty sure the reassignment will break. Yep, type of left-hand side, a variable reassignment must match right-hand side return type. And it's saying, hey, bar, trying to reassign it to 34. The left-hand side type is a function. The right-hand side type is an integer. You can't do that. Very cool. Very, very cool. And the same thing would happen if there was a pointer. Say, hey, you can't assign a pointer to a number. So cool. So what if x was a pointer to an integer, and we reassign the dereferenced x to 69? Then we have this bar integer, 42, and we return bar from the entire thing. You get mismatch types. Oh yeah, right. here. So what we can do is pass in the address of bar, right? We still get mismatch types. Return type of last expression in function does not match function return type. That's right, this returns an integer and this returns a pointer to an integer. So we need to return 0 or some other status value. We'll call that success, right? Type not found null. Type is not found in environment. Hey, I screwed that one up. So something is still broken. Type not found null. That's probably the variable declaration with the pointer thing. Is that what this is? It's probably something to do with that in type checking. So my guess is that when we call like parse get type, negvorsa says and bar. Yes, and bar. That is right. Am I misremembering my own syntax? Let's check out the pointer file. So yeah, it's and number. So maybe we need an actual, I mean, and bar, the return type of the address of bar should be a pointer to an integer. Because this would work, right? Have like pointer to bar, which is an integer pointer. This should work. And if it doesn't, nope, still type not found null. Wonderful. What if we do a reassignment? Nope, still not a reassignment. So what are we getting? We're getting a... Can it be at integer in the parser? Maybe. The parser is definitely dealing with at integer well. You can see we have a variable declaration here, which is a pointer to an integer. And then we have a variable declaration of pointer to bar. Where's pointer to bar? Pointer to bar, which is a pointer to an integer, right? We have, what else? What else? What else could be? Type not found null. Not a great error message. It's during type checking. So what would happen? Let's just guess and say, are we in here? Here? I'm curious, are we here? We are here. Look at that, chat. So this type, yeah, makes sense. This is simple. This is simple. While temp node does not equal a symbol, while temp node children. So we basically just have to recurse into the pointer. Negvorsa says, cool, so did you copy the result from stack to .data section? Yes, I did. Yeah. Because they're technically just both memory calculations. If we look at code.s, you can see that basically, whenever you use move, this with the parentheses means that offset the memory address bar by rip, which isn't really important, just means get the memory address of bar. But yeah, so this global.data section, we move into racks and we can use. But the idea, when we get this next one up and running, is that bar as a global variable in the .data stack, we will pass an integer and change it from a function environment using the pointer. But yeah, you're correct. You are absolutely correct. Hailed with code 5. Okay. So while temp node children and temp node type does not equal children. I see. So I have to say effectively, do I have another temp node? I need another temp node, please. What is it? I can use value, possibly? Okay, what we have a lot of nodes here. We have value, temp node, result, and type. I'm sure I can use one of those. We've used value for the function. We've used type for the return type of the given parameter. We have result, which we are writing into. So it looks like we're just gonna have to, right? Do we need value after this? Do we use value? We don't actually use value. Value is just used to create temp node. So we could say, we could update value. This is horrible, by the way. I wish I could just create nodes. And also sometimes you can. So maybe I should just try. Yeah, why not? So effectively, our problem is that we have a type that may be a pointer. So we have to go all the way down to the actual type symbol and then get that. So this makes sense. And it's in temp node children next child. So we're going to say value is equal to temp node children next child. We're going to say while value children and value type does not equal node symbol, value is equal to value children. Please use value to get the type. We got a variable access pointer to bar and a variable declaration pointer to integer. That's right. So let's see. What do we have? Our expected type. What's our expected type? It would be our pointer to integer. So what's our actual type? Print that out, please. We're not here anymore. So print me out my value. I just want to see it. Symbol integer. Okay, so I have the type symbol now in value. And in result, I have integer at the actual literal type. So I don't need result, right? I do need result. And I also need to convert type. Ah, balls. So I could just do symbol comparison. So I could get symbol of left-hand side, symbol of right, or yeah. But the return type of the expression in type, why does this return a type symbol? I don't feel like that's correct. Maybe it is, though. Maybe that's what we decided on. In any case, so we have a variable declaration with pointer integer. And our actual type that we have been given, I know this is probably horrible to read, I'm sorry. So we have a pointer to an integer like this. So we need our result written not into result. Okay. So we're going to say each time we're in here, we can't update result. God damn it. Okay, we're just going to try and create a node. Hopefully it lets us. Most of the time it doesn't let us, but we're just going to try. So we'd like to create a node pointer which refers to where even are we? So this is just going to be type iterator, and it's going to be equal to value, right? And every time we do this, type iterator equals value. So basically, can't we, I guess that effectively would just mean this, would it not? Because value refers to, let's see. What does value refer to? We're doing another one, boys. Okay. So we have a pointer to an integer, which is our our return type of our actual expression. We have a literal integer, which is just we have a pointer to an integer, but we got the literal integer type because we had a symbol integer and we turned it into this node. Then we have symbol integer and value. So value gets converted into result right here. So what this means is that, oh Christ, we have a node type, and we need to get result. We basically need to place result as a child of itself. Does that make any sense? I think I just said nonsense. So result children, right? We're going to have to do some node copying. Because the thing is, we have a... this is such a messy type system, by the way. This is evidence that I am not good at what I do. In any case, I really got to stop streaming soon because it's late, but it's okay. I'll keep going until I think I get this done. Or I get too annoyed and we just end on a sour note. But I think this will be fine. We'll be able to get this done and working. So we have a pointer to a type, right? So we would like to set result. It's like we need this iterator. Okay, so we're going to need type result iterator. And it's going to equal result. Because we want to write into type result iterator. So nothing should change in this case. Correct. But if every time we do this, we say type result iterator equals value. So now result is equal to none. So each time we do this, we have to create a new node. Right? We're basically recreating the pointer in direction here. Negvorsis says that the function has only side effect to change its argument and the result gets ignored. Absolutely, that's the idea. We're ignoring foo because it just returns 0. It's just a success, right? But its actual side effect is operating on x to update it to 69. And x is a pointer to bar, so dereferencing it should be this pointer, which means we get bar, and bar should return 69. For now, we're doing type checking. So we're going to do it a little differently if we can. We're going to say one more pointer. One more level of pointer in direction. Why not? I like that. That's silly. So we have pointer. Oh, we're nearly there. We're nearly there. We just have to say the type is a node type pointer. And then we have to node free this thing when we're done. So we are going to, I guess, node free result children. Once we're done. Yeah. So we now have pointer int 0, none int 0. So it's like this didn't work. Ah, because this first type. Interesting. Interesting. So we need to say type result iterator equals result. But we need to update it and keep adding children to it until we're done. We're done. Yes, so we build this pointer tree, but the original type result, so result, so basically we should say, okay, we're basically just going to do result type equals node type pointer. Otherwise, we'll just have a symbol and get right through here. Then we update value children, right? So this iterates the linked list. And this builds a type result tree. Exited abnormally with code 116. That's a new one. What do you think we did, chat? Maybe it's this node free? Is that the issue? No, it's not. So, the idea is we just build this tree. Why no work? See, we did it. We did it, chat. So we have, basically we get the return type of our given parameter, which is this. And then we get the expected type just from the symbol of the parameter. And from that, we build this result type, right? And result ends up being this, which means type compare will not happen. We'll end up here, right? And even if we don't free, we make it here. We exit abnormally with code 1 still. We made it there. Made it there so we can free the children just fine. But then we say iterator equals next, temp node equals next. So we don't update temp node in here. We don't update iterator in here. Yep, we just use it how we used to. So it says while iterator and temp node. So then we should fall through to here. No? Do we still exit one? We can still exit one. So the issue comes further when we break from here. Tell me this. Still exit abnormally with code 1, which is exactly what this exit will do here. If we put it to 10, we can show that we're in the same spot. But if it continues, we get code 116. Here. Okay, so we're gonna end up, stopping this debugging session, which we kept open that whole time, which is hilarious. You think we're gonna reach an exception? We didn't reach an exception. What do you think we did? Dereferencing null pointer last expr. Yep, that's true. Should fix that. Either way, that's not what I'm worried about. I'm worried about why it's not working. Hello? Does it just go away? Okay, maybe we're reaching the wrong program. Which one are we compiling at this point? Simple Func. Simple function. Hey, look, there's an exception. Child was OXFFFFFFFFDF. That's a negative number. In node free, what child? Why is child not null? What are you talking about? What is root? Root isn't a thing either. What the hell's going on? So in node free, we know that's what the issue is. And it calls itself a whole bunch. So node free from here. So trying to free the program is the issue? Seriously? So root with type of 13, that's the program. Child with type of 3. Does anybody remember type 3? 0, 1, 2, 3? So function. So we have function, right? Makes sense to me. And function ends up calling what? With a child of type of 0, which is none. Well, that doesn't... does it have children? Like, where did we end up here? Let's go 1 up. Look at child. Completely wrong. Root. Type 9. What is type 9? Pointer? Okay. It's looking like that stuff we just did broke a whole bunch of things. So result. I'm so confused why this is a problem. So we just use value. We'd never dereference value or like write into it. Or dereference temp node. We never dereference temp node and write into it. Ah, we do say temp node equals temp node next child, but which we technically shouldn't do because we have to free temp node. You know what I mean? Like this should be another iterator. Let's just try and rename temp node. And Neg Vorsis says, so you used a free pointer, right? No, I did not. I don't think so. This is a literal node pointer. It's still an object on the heap. It's valid here. It just has a problem that next child is set incorrectly to some value that isn't null. See this? So somehow next child is being screwed with, which really doesn't make sense. Because we just node allocate is all we do, right? And node allocate sets everything to 0. It does a calloc. I don't know. I don't know. We're figuring it out. So exception thrown, blah, 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 because our program wasn't right. So our program not being right, how could that happen? So our program is pointed to by iterator, but all we do is use iterator like this. So I don't really see how that could affect anything when all we do is use it to get the return type. We then have type. We never really write to type. We just used it. We use it in this comparison here. And we print it out. That's true. We also do that. So result children we have to free because result is going to be freed down here, but we added a bunch of children here. Possibly. Or we didn't, right? So every time there is a pointer, set result type to pointer, which really should just do the same thing over and over. It's not a big deal. Just avoids having to check this condition twice. So now we would update value, and value refers to our temp node children next child. So this is our actual type symbol, right? Our expected type symbol. So what if we just rename that? Okay. Normally it doesn't let me create variable nodes. Hey, look, it worked. So generated code at output file path S. Hilarious. So were we using value, like dereferencing it down here? We're not dereferencing value. I don't get it. I truthfully don't get it. If anybody gets it, that would be great. But I don't get it. Okie dokie. So now, can we just put and bar here? We can. Baller. Okay, now let's look at the code it generates. So now, the main function, it simply does a variable reassignment to the integer 42 of bar. So bar gets reassigned to 42. We call foo, and we load the effective address of bar into racks. We push racks and call foo. So our one argument is our address of bar. In foo, we then reassign something to 69, right? So we move 69 into racks. We dereference a variable access of x. X is our local variable. So we go to that memory address and read it. Then we dereference that memory address. So our address stored at x is dereferenced through x. So x is read from. R10 contains an address. R10 with parentheses around it means dereference this memory address. So this is actually writing into memory racks, which is 69. So we write 69 into racks. That's perfect. That's exactly what we want to do. Integer 0. Yep, this is our return value from the function in racks. Then we get back here and we say, okay, we don't need to restore racks. We weren't using it. So just add 8. Add 8 to the RSP again. I'm not sure why we do this twice, but that may be a bug. But it probably is not. Sub 32. Add 8. So this is a push add. Oh, so this is eating the variables off the stack, the parameters that were passed, and this is just eating the racks that we didn't save. Whereas if we had racks in use, we would have popped racks like that. Okay. Then we access bar for our return value of main and store that in racks. Let's run this bad boy with our little incantation. Shell command failed with code 6.9. Hey. So we assign bar to 42. We call foo with the address of bar and then return bar. So if you just looked at this, it'd be like, well, bar should be 42. That's what it should return, but it actually returns 69. Oh, that's so pog. And can we do like x equals x plus 35? I don't think this is going to work. I don't think we've handled this type of code. Yeah. It says, what? Mismatch types. Dereference may only operate on pointers. X is a pointer. So we have some major issues happening there. But that's something we'll have to work on another day. For now, we actually have X being able to be dereferenced and updated no matter what we assign it to here. We will always return 69. Look at that. Ain't that beautiful? Neg Vorsis says, so you free value in the type checker. Oh. Yeah, that's why that fixed it. So we were freeing this node because we were assigning it to value, but then we didn't assign value to null, so we would free value, which is something we should not have done. Same thing with temp node here. We're gonna have that same issue, I think. Because temp node will eventually be null, which is not what we want. So what is temp node here? Temp node actually refers to, hopefully it'll let me do this again. What? Node pointer. So value children. That's function return type. No, function parameter. Yeah. So we'll just say expected parameter. You still gonna let me? That's right. I didn't update temp node all here. So with all these temp nodes, there should be expected parameter. Expected parameter. Okay. Expected parameter. A expected parameter. And if expected parameter, we can say expected argument, expected parameter, right? That's how that'd work. I think that's how that'd work. We can put the function first. Okay, if iterator does not equal null, that means our given argument was incorrect. So this just prints the function. It says too many arguments. Hey, it worked. Hopefully it worked, at least it passed. The program runs in the same way that it did before. Code is still generated in the right way. We're going good. We're going good. So we're gonna take a look at simple func. So this would probably be better renamed as pointer side effects or something as an example, but for now we're just gonna leave it out. Okay, what did we do? So in the type checker, we renamed a bunch of things. That's effectively all we did, but it fixed everything. We didn't do any parsing, nothing in Cogen. We just fixed the type checking. So, type checking, make function call parameter type checking more robust. Sure, we'll go with that. And then we will push it. Yes. Alrighty, we are coming up on the end of the stream now. It's been 3 hours. Down below in the About section, feel free to check out the GitHub, and you can see the fun compiler and all of its progress. You could even build it yourself. You don't really need that many programs or anything. And it's the MIT license, so feel free to do whatever the hell you want with it. I'm very curious to see you guys run this, write your own programs, and maybe even contribute a pull request or two if you want. Either way, I'll still continue to work on it. With that being said, we should now be all done for today with the stream. We made a lot of progress. We did a bunch of stuff. We fixed parsing of if and else. We did scopes. We did so much today. I'm really happy with our progress. I want to thank everybody that has watched live and everybody that is watching the YouTube video now, I guess. I would like to thank you all so much for watching. It's been a great time, and we're going to do this again. We're going to continue work on our compiler, make it more robust, make it so we can dereference a variable that uses the dereferenced variable as the value. Adderson28 says, that's a lot of progress. It was great. Thank you, Adderson. I really appreciate that. It really was great, and it was great to have you here. Adderson says, have a nice day, Lens. Thank you for the stream. Thank you, Adderson. You're so polite. I really appreciate you. But we will be out of here in no time. I'm going to do my little ad spiel, and then, yeah, then I'm just going to end the stream and say bye. So thank you, everybody. Down below, there's the YouTube where you can check out every previous broadcast that we have ever done. You can see every bit of code that we have ever written for our compiler in that YouTube series. So I would recommend going to check that out if this interests you. There's also a previous series on making a suicidal AI bot. So that's interesting. Go check that one out. It's only like 4 episodes too. It's not 20 episodes of 6-hour-long videos like the compiler. But it's there. There's also the Discord down below where we would love to have any and all of you join. We have a great time. Hey, there's so much happened I missed. Oh god, I gotta catch up. But yeah, there's a ton of stuff in the Discord. We are all friends here and have a ton of fun. You can get code review if you would like, and I make announcements every single time I go live. You will never miss another stream again. With that being said, there is one more, a link down below, and that is the big PayPal donate button. You do not have to press it by any means. You do not have to give any money. But if you are feeling generous and are feeling entertained, I would of course appreciate any and all donations that come in. If you leave a message, I will read it on stream as long as it's appropriate. And if you leave your name, guess what? I'll read your name in your message. Crazy, right? Mind-blowing. But that is the donation system, and I would greatly appreciate that. I don't have any other source of income, so even $1 helps. But don't give me your money. If you need money, you keep it. I'm in America. I'm in a prosperous place. I'll be fine, I'm sure. Right? I also want to bring up, PayPal has a new subscription model. So it is possible for me to have subscribers that are not part of the Twitch affiliate system. So I could have subscribers where Daddy Bezos does not get a cut, which is kind of intriguing to me. So if that's intriguing to you guys, be sure to let me know, and I can add a subscribe button down below next to the donate button, and we can skirt around Daddy Bezos without giving him our precious dollars. So if that interests you, be sure to let me know. And thank you so much. You can also make monthly donations, which act much like subscriptions. You'll just won't be in a special list, effectively. In any case, that should be my entire ad read done. I did PayPal, I did YouTube, I did the Discord. Right here on Twitch, there's things you can do as well. You can hit that follow button. You can share. If you have programmer friends, go tell them. Say, hey, look at this guy. He made a compiler. Or don't. Say, look at this idiot. He made a compiler. I don't care what you say about me. Just say me. Right? No, I'm just messing with you. Please be nice. Please be nice. But thank you so much, everybody, for watching. That's going to be my 3 hours for today. All up. All done. Bye-bye, everybody. Love you. Thanks for watching.